Here's audio. Here's video.
Oh,
So now we're live.
crazy.
Hello everyone.
Hello.
So now you're in control.
Can you make it so I can see
Oh, you're in the chat.
yeah, the stuff. Oh, I said John. Hey, John. I was live.
Yeah, I'll get my headphones so that I can monitor the Discord call.
Okay. Hey, Edric. It's all Gucci. Nice. How's the audio? Having a watch party. Edric. Yeah, we'll start in like 2 or 3 more minutes. It's my first time doing live stream, so I'm pretty excited.
Yeah. Hey guys. If this second. I'll put on headphones so that I don't distract Gustavo, but yeah, I can watch both at the same time.
Dang. So you can see the chat.
Yeah, they can see the chat. They want you to talk to the mic and see if yeah, he's not saying anything at the moment.
Hello, testing. How can we make it so they can see the screen? So this is how I'm gonna talk normally. I have the mic pretty far away, but I think this should be good audio levels. I'm not too certain.
Alright.
Okay, so is it full screen?
So we're good to start now.
Cool. Yeah, we can start. Hi guys, I'm Gustavo, president of Moby. That's Diego. He does everything for us, so he set this all up for me. So shout out to Diego. So yeah, just a quick rundown of things we talked about in the first meeting that we had. Moby, we were kind of just a computer science group here at UTA. Very local, we're not national or anything, and we kind of just like to hang out. On Fridays, we do social coding. We kind of just hang out, sometimes play games, we talk about projects, resumes, internships, basically everything we can do to further our level of computer science. Yeah, we learned real world development skills. Most of you guys are on the Discord. If not, there should be a link somewhere. Our website for sure, utamoby.com. Here's some of our members that I went full-time and went to work at. Milo, this one's important, is our Moby mascot. This was our last president's dog. Membership, so it's just free. We do give out t-shirts, so when we do go back to in-person classes, we'll be able to actually sell those t-shirts. But for now, we're not charging anything. It doesn't cost anything to go to the social codings to just kind of watch this workshop. Weekly events, I talked about every Friday. If we don't have a workshop, we start the social coding at 5 p.m. Otherwise we kind of just do it right after the workshop. Moby Leak Code, we do that every day, every Saturday at 4:30. We kind of just work on Leak Code again, talk about resumes. If you don't know what Leak Code is, it's basically a website where you can practice technical interview questions that a lot of companies give out. Cool. So we can hop into the introduction to NoSQL. So as far as this workshop goes, I'm assuming you know a little bit about SQL. You may or may not have taken the database class that is given to you your junior year. That's fine. So as far as to give a quick recap of it, SQL databases, they're all based off the SQL language. It's based off a table and rows and columns, so it's very structured. You know exactly what you're expecting from the user, and you're not allowing them to give anything else. So that's why it's the schema is explicitly created beforehand. So as you can see on this, I'm assuming you can see my cursor on this bottom left side. This is kind of some SQL code that lets you create a table, so you'll know exactly what you want to bring in. There's different database models for SQL, but all of them use the SQL language. So to give an introduction as to what we're going to do for NoSQL, we're going to talk about the benefits, disadvantages, different types of NoSQL, and I want to emphasize some key concepts as to why basically NoSQL was created differently from SQL, and why it's technically considered faster than a relational database, which is a SQL database. So starting off, if we think of very big picture, NoSQL is no different than SQL. They both store data, and it's to store data, it's to retrieve data. The only difference is you want to use one or the other depending on your use case. So if you want to retrieve your information as fast as possible, you would use one. You would use one versus another. Versus if you want to ensure certainty that the data you're receiving is actually accurate, or let's say only one person can edit this data at the same time. So these are kind of reasons as to what you would think about if you would choose SQL versus NoSQL. As I talked about before, kind of in this picture right here, it kind of stores in tables, rows, and columns. SQL does. But here on this right side, you can see how it's stored for NoSQL. It's kind of just one big blob. If you're familiar with the language JavaScript, it's kind of just a JSON object. Of course, related data, it doesn't have to be split. So for example, for SQL, you would have a table for, let's say, your authors, a table for your comments, and then kind of like a bigger table that references all your tables. These are called your primary keys and your foreign keys. So they kind of, that's how they all interconnect. But as far as NoSQL goes...
Mosquito.
Oh, thank you. As far as NoSQL goes, they don't care about any of that. So this is why it's known as schemaless. They're not too worried about how they retrieve the data. All they know is they're receiving data, and it doesn't matter if it's right or not. You as the programmer need to ensure that that is correct. For that specific reason, we can go to that third bullet point, and this is why those queries are fast. Because there's a lot of overhead whenever you're making sure you're retrieving the right data or pushing the right data. So for NoSQL, that less overhead means you get faster queries. In addition to that, for that second bullet point, horizontal scaling, we'll go into more what that means, but essentially because we don't care about all that overhead, it allows us to use a lot more machines and thus get a lot more bandwidth and get more, retrievals. And the fourth one, as I talked about, it's easy for developers. It's up to you to post that data, but of course you also do have to be careful since you do have a lot more access. Disadvantages, there's this term called ACID. We'll speak on that in a future slide. But that leads to data inconsistencies if you don't support ACID transactions. And also, another disadvantage, it's not optimal for heavy updates. So if you are updating one specific deep into the root of a document, then it will take a lot if you're doing all of the documents in the collection. Going back, I don't think I spoke about documents in collections. Just think of them kind of as rows and columns. As that first bullet point says, they use collections and documents. I think my face is covering it, but here is a document and here is a collection. So one there can be multiple documents in a collection, and we'll do a small live demo on that as to how that works. Relations are not implicit, so what this means is, let's say you do have two different collections. One of them is for, let's say, your user info, and another one is related towards like images. So what you would do is, if you need specific images from your user collection, you need to kind of give that reference to this other collection. But what can happen if you kind of mess up your code, if you delete one but not the other, and since they rely on each other, you can kind of mess up the database. This doesn't happen in SQL because it forces you, it lets you know beforehand. Whenever you try to do something in SQL, it kind of screams at you, hey, you're doing something, but it's conflicting with another table. Please fix it first. 4 different kinds of NoSQL. So I kind of mentioned MongoDB kind of in that title. So this one that falls into document databases. This is what I've shown you before in that previous picture where it has, let me backtrack a bit. This is kind of document style. It's just all one big document, and it's the blob, like I said. You just put it in the database and then it's there. Key value pairs, think of it as a document database, but a lot smaller and more simpler. This can be used for stuff like user preferences, some simple caching. This is when you would use those specific databases, because it's very easy to just get the key is unique in the database, which is the user, and get that specific value, which is their user preferences. Going back, document databases are a lot more general purpose. Wide column stores, this is stuff, there's a database called Cassandra. Just think of it as storing your information in your columns as opposed to rows. This way, if you want to grab a bunch of data just specific to one specific column, then it's a lot easier to do that, and it allows for very fast querying. A lot of social medias like Instagram use these wide column stores. And then graph database, it just kind of connects nodes and edges, so you can kind of see a better tree structure of it. Key concepts. So this is one of the first key concepts I want to talk about. And when I mentioned earlier, NoSQL allows for horizontal scaling. This isn't to say that regular SQL doesn't allow for horizontal scaling, but it's just naturally it's a lot easier for NoSQL, and we'll go over as to why using a theorem in the next slide. So for horizontal scaling, that just means you're adding more computers, you're adding more servers. So this way, when you can take in more queries, so they can spread out through different servers, as opposed to vertical scaling. This is what SQL is known for. This is how you can increase SQL bandwidth. You would just increase the RAM, the CPU, and of course that can get expensive because it's a lot easier to just add more servers than it is to add more CPU or RAM. Another key concept, this is when I was talking about ACID. So first, there's something called, in computer science, there's something called a transaction. Don't think of it like as a transaction from a bank, but it can be related to a bank. So for example, in the computer science transaction term, it means you're doing a collection of things, and it either all happens at once or it doesn't happen at all. As you can see in that first, when we talk about atomic, the data all changes together, or if it fails in between, then it reverts everything and it acts like nothing happened. Consistent, the C in ACID, kind of just means that the data every node wants to receive. So if, let's say, you ask for a bio from a user profile, if multiple people ask for that bio, everyone should receive the same bio, as opposed to kind of like if someone updates right away and then you're getting an older version. Isolated, this kind of just means that, well, yeah, no other process can change the data. So if I'm changing my bio, no one else can change my bio. And durable as well, then it must be persistent. That's why it must never change back to its old ways. Maybe we can go over some examples first. So I'm going to backtrack a bit and talk about... Actually, can you show the comments? Is it good?
Yeah, I see the comments.
I can't really see. Okay, looks good.
And the other comments. Yeah, they're all good.
Awesome. Perfect. So maybe I can go over some examples as to like when you would use SQL versus NoSQL, speaking specifically on like horizontal scaling and vertical scaling. So obviously more internal stuff. So let's say you work for a company and you have a service that needs kind of, let's say, not even high CPU. You can kind of focus more on SQL because you're not really focusing on users getting that specific data right away. You don't mind if it takes a little while longer, so you don't really have to up the RAM, the CPU. Same thing for horizontal scaling. If you do have a let's say millions of users, you kind of do want to go more towards NoSQL, just because you can increase that bandwidth. And then when speaking about transactions in ACID, so SQL is very known to be ACID compliant. So quick recap again of what ACID is. It means that no other node means a server, so no other server can affect any information that you are currently changing. And so let's say if you change your bio, you immediately get the updated bio from other nodes as soon as you update it. Whereas, let's say you do NoSQL, if you are to update your bio, there could be a small time frame when, let's say, I go to your profile, I can see your bio, and it's going to be the old bio, and then maybe 10 seconds later, 20 seconds later, it's finally going to update, and then I'm going to get the proper information. So you can kind of see where this is good and bad. Of course, like 20 seconds to you updating your bio, we're not really too worried about that. But let's say you work for a bank and you grab the wrong information as to how much money I have in my account. So if I do a withdrawal in two separate places, let's say online and in person at the same time, we want to make sure one happens before the other. So this is where you must be ACID compliant. This is why financial companies, as far as their financial services go, they have to use SQL, just because they need to ensure they're always getting the correct information. So there's this thing called the CAP theorem, and it essentially explains why NoSQL is considered faster than SQL. Can you turn off? Sorry, 1 second. Technical difficulties. Oh, cool. So there's three things in that CAP theorem. As you can see, it's consistency, availability, and partial tolerance. And the theorem states you can only have two out of the three. This doesn't say you can't have like all three, but as far as having 100% of each one, you can't have 100% of that of all three. So this is imaginary. You will never achieve. And this is why NoSQL is considered faster. NoSQL chooses availability more over consistency. This goes into like the reason why some nodes might not have the correct information right away, and it might take them a while, because SQL wants to focus on speed and you getting your information right away. Whereas SQL, they focus more on consistency. So this means that you're always going to get the right information. If someone updates something, you're going to get the correct answer immediately after. So going into why NoSQL can scale horizontally more, which means adding more servers, is just simply because they can put information into more servers. I can put, let's say, my bio in a server in the US, and then a server in Asia, and then a server in Brazil. And when I update my bio, they can still hold on to my bio and give the information out. While as SQL, they would refuse to give the information out until it retrieves the proper information. If you've taken a database class, you know what joins means. So for SQL, we talked about how they have different tables. I'm gonna skip quickly over to this slide right here. They have different tables. So let's say if we wanted to reach this post table, it kind of references this author table and the comment table. So joining would mean we would combine these tables together if we were to say that, hey, we want all this information. This is why it would take a while, because joining is very expensive. Whereas, as you can see on this left side, NoSQL, you really wouldn't worry about that, because all the information is kind of together at the same time. Some intuitiveness that you can see is, let's say you only wanted the upvotes for this specific post, then this is where NoSQL would kind of not really, it would still not really have as big as an advantage as it would be if you want the whole thing. So if you just want the upvotes, it's kind of the same as just going to one specific table and retrieving the upvote. So where NoSQL excels in is when you really want to grab all of the information. And this is very common among actual projects. Giving a quick summary of what I was talking about, NoSQL is kind of just faster due to no overhead in the schema. If you want to add a new property to your application, all you have to do is write it in code. Whereas in SQL, you would have to update the table, and let's say if you have a million records or more, that could be very expensive, and just updating the table alone to include that new column, that could take sometimes up to a day. So that's one of the main benefits. So I can give you an example. Let's say you do have a social media profile website, and you give the user the option to edit the way they want. So let's say you have your profile picture, your bio, some pictures, and let's say they can update it to where they can add their own custom thing in between. They can remove the bio if they don't want. If this is the case and you do it in SQL, you're gonna have a lot of null values, because let's say they completely remove the bio, the column is still there, so you're wasting space, but it would just be null for those that remove the bio. Same as when you added a new, whatever, let's say a new section. If they add a new section, that means they would have to add a new column, and if that column is very unique, a lot of those million records would just have null values. So this is where, again, NoSQL would kind of triumph over SQL, because it doesn't matter who has what, because it's kind of schemaless. So in one collection, going into here, let's say we have a rating, and someone gives a rating of 2.2. In a similar post, let's say they remove ratings because they don't want to. Instead of just giving a null value, the rating just wouldn't be there. We would save storage, and we don't have to worry about kind of all of that connections together between NoSQL, because it doesn't care. I can't see. The next bullet point, of course, talked about it can scale horizontally. So all we have to do is just add more servers. It allows for semi-structured data to be easily stored. This is kind of what I talked about in that last example. Custom widgets you can let your user put on the website. One thing to note, the right side is kind of the bad things about SQL is it's not asset compliant. So again, this is why financial companies, for the financial services, they don't use NoSQL. This isn't to say that it's not possible for NoSQL. It's just naturally a lot harder to get it to work. Same thing for SQL. You can do horizontal scaling. It's just naturally harder to get that to work. And of course, at the end, NoSQL, they really emphasize availability, your speed, as opposed to getting that consistency of data between multiple servers. As far as the live demo, it's going to be kind of super simple. We're kind of just going to go over this table right here. So for SQL, if we wanted to kind of create this information, we would first have to create an author table, kind of give it those specific IDs, name, username, and then we have to create a comment table. Kind of give all the information we wanted, and then we finally create the post table, where we kind of reference all of these tables and then give the proper information it wants. Whereas on NoSQL, all you would have to do is just insert it, and then you're done. So that timing, for as far as like efficiency, is really kind of the way to go. So not only for, let's say you're doing a hackathon and you want to do stuff really quickly, you would of course use NoSQL. And again, if you also want to just be a lot more flexible in your application, again, you would use NoSQL. So I'm going to do my best to try to transfer this over. So, Diego, let me know what you're seeing right now.
Connect to hosts.
Okay, perfect. So this is a MongoDB UI. So we're kind of just going to use MongoDB because it's kind of very popular, it's very easy to use, and I can do it locally. So we're first just going to create a local server, and then we're just going to append the information that we want. MongoDB Compass is the name of the UI. Their cloud storage is called MongoDB Atlas. Don't Unless you have this already downloaded, it'd be best to just follow along. And it's super simple. We're just going to show you how to do that. So it pre-fills everything, the name, localhost. This is the natural port number it's going to use for the server. So we're just going to connect that. And here is our databases. These are some random ones I've created beforehand. This has just different databases, so we want to create a new database. And we want to name it something. So in regards to the post that at the end of the slide, this is like a Reddit post because it had upvotes and downvotes. And this is like a collection name. Think of these, if you really want to compare it to SQL, just think of these as tables. So let's name this, let's name the database Reddit, and let's do post, all lowercase. Alright, so if we just click on that, we can see the collection and no documents. Documents, if you want to compare it to SQL, just think of it as like your rows and columns. So I'm going to switch over to the terminal. So give me 1 second. Cool. So I also downloaded the MongoDB CLI. So all I have to do is just type Mongo, and then it takes me to the default port, which is the 27.1 something. So if I press enter, this is what I can use to interact with my database. So if I do like show databases, we do have Reddit admin config local test. So we want to use the Reddit. And so now that we're here, we can kind of just create something random. So database dot name. Then we want the collection name. And as you're gonna see, a lot of this is kind of just very intuitive for coders. So instead of actually learning a new SQL language, all we'll have to do is learn JavaScript. JavaScript, if you're familiar, it's for front end, for back end. MongoDB is kind of very tied a lot with JavaScript. So we're going to name, I think it was post, singular. Let me confirm that, yep. And then there's a lot of methods that we can use. So looking at their website, the one I want to use is insert many. And here we would just put the information we want. So let's just create some random information. So let's create an array, and let's create a for loop. So can you hear my typing? Is it annoying? No. Okay. So let's do like 100 records. So let's do push. Let's see what we had for the slide. We kind of just had random stuff. So let's do an author, and then let's name him. Actually, let's do another thing. Actually, for simplicity, I'm just gonna give him a name. So his name's gonna be Majin Buu, and let's give him another value, a rating, and let's give that a 2.2. We can just do one more thing, kind of the post description. So this is and let's give it something unique to each one. So actually the rating, let's make the rating equal to I. So now let's close everything. I'm missing this for the JSON object. This closes the JSON object. We're closing the method as to what we're pushing, and we're closing the for loop. So if I print out what I have, think of these as documents. So this document has the author. I should have changed their name for each one, but that's fine. Each one has a different rating, and up to 100 of them. So now, what's up?
All the comments are saying that the typing is ASMR.
Is it really? Oh no. Yeah, I have an old keyboard, so it's very
soothing.
Oh, okay, gotcha. So yeah, so as I spoke earlier, instead of having to learn a whole new SQL language, which by the way is also very good to learn for your computer science degree, because it's still SQL is still very used in the industry. all we have to do is remember the methods and look at the database. And look at the API. So we want to use something called insert many, and all I have to do is give it the variable name, and this should work. So let's give it the collection name. That's what it was, and now we can do insert many. And let's see if that works. Scroll up a bit. Okay, so it kind of just replies back to you, acknowledge true, so it kind of inserted all of these IDs. These are just unique IDs that are given to the document. So if I were to go back to the UI to help you see it, if I were to refresh this, let me find out how I can refresh this. Oh, it does it by itself, perfect. You can kind of see all this information and everything just kind of put together. So these are one specific document again. The collection is what I showed you earlier, which is the name post, and the database is Reddit. So I know what we did was, that's kind of the end of that live demo, but I just kind of want to emphasize how much harder it would have been if we were to do it with SQL. We would have, again, going back to the PowerPoint, I kind of just wrote down here in comments what exactly we would have had to do, and each one it kind of would have taken a while. So we kind of had to create all of these tables and match them with the keys, the primary keys, their foreign keys, and then we would have to kind of insert that proper information. So that took I don't know, kind of like that can take like up to a minute versus the SQL, which can take up to maybe 5 or 6 minutes. So that's in computer science world, that's actually a huge difference. You can save a lot of time if you need to do that over and over again. So yeah, that should be the end of my presentation. Is there any quick comments? Not quick. They can be complicated, or doesn't matter. Although I can't see the comments. Can you make it so I can see the comments?
Yeah. Can you show a query on your new database?
Can I show a query? Yeah. Can you see my...
I'm gonna re-add the screen.
Okay, let's give it a second. We're gonna go back to the screen, and we're gonna look at this. Actually, I think I have it pulled up too. So this is the MongoDB API. If you don't know what an API is, it's kind of basically a library of code that you're just grabbing from from someone else's project to your project, so you can use this code in order to do what they did. So we pulled in that API, and then they always have a documentation as to all this information that we want. I used insert many, and you can kind of see how what it wants from it. So I gave it that document, which was a list of documents, and it kind of returned me that information that, like, okay, we're acknowledging that it's true. We're returning all of the IDs for it. So as far as to grab something, we can do find one. Find one works. Find many probably also works. Find one and delete. So here we can kind of see what they're doing. This is the collection name, and we're doing find one, and you can kind of see what it wants by looking at their documentation. So it kind of just wants the fields that we're looking for. So I guess what we gave it was unique to it was what was it? The rating. So let's see if I can figure that out. So it would be database dot. Oh, you can't.
Yeah, it's not showing that.
Yeah, that's what it was. Database dot goes post dot find one. Or actually, I don't think find one wants anything. So let me see if I can just do it like this. Yeah, so find one kind of just grabs a random one. I don't think it's random, I think it's in order. Yeah, so you'll always get the same one. If you want to find, I'm not going to go back to the website, but there's another method that's called find instead, and here you would actually give it a query. The query is optional. You can give it an empty JSON, but we don't want that. We want to look for a rating of, let's say, 22. And here is that information. So it kind of just, it gives you the whole document. Tying it back to the slides, so all you have to do is know one key value, and it will return the whole document. Going back to why this is important, it's very common in the industry for you to want all of this specific information. And I guess this is a good time to talk about what I said in the beginning. NoSQL is essentially just a different way to store data, but it's not like magical. You actually have to know what you're doing. For example, in NoSQL, you have to know when to create a new collection, when to like group all of this blob together, and you can't just do it randomly, or else you're going to kind of have to do too many queries, and it's going to take a long time, and then it just won't be efficient. You actually have to do your research beforehand as to what you want to group together into this specific document.
Edric is asking if you'd be able to rename Boo, the author, to the Moby mascot, Milo.
So, actually, let me just hop on over to the API again. So I'm going to switch screens, and you should be able to see something that looks like find and modify. You can see a lot of these methods, they're kind of very intuitive as far as being able to understand what each one does. So as far as find and modify, let's see, I can read about it and it'll tell me if it does what we want it to do. So I'm just reading through it to make sure it's what we want. So this has a lot of property options. I'm going to move this real quick. Let's try, what does update one do? Okay, so this maybe might be more of what we want. Updates a single document within the collection based on the filter. So I think that's exactly what we want. So I'm going to hop on over back to the terminal. Cool. So db.post. Post is the name of the collection, as we spoke about. And we want to do update only one of them. The first thing that it wants is the filter, and filter is required. So let's get this specific one, the rating 22. And the next thing it's looking for is the update. So this is required as well. The modifications to apply. So let's say we want to change, I believe this should work. So it's asking for the author. And let's name it Milo. And let's see what else it's looking for inside the method. Looks like everything else is optional, so let's see what that does and if it returns an error. So this matches with that. This object matches with this one. Closing the method must contain atomic operations. So let's see what that means. Okay, yeah, I can debug that maybe later. But yeah, so you can kind of see how easy it is to look at that API though. And if you do run into errors like I just did, all you would have to do is kind of look at the frequently asked questions, Google it, or stuff like that.
Dope. There's dabs in the chat.
Dabs, nice.
John asked a question, but it's a little complicated. I don't want to ask.
It's a complicated question?
I'll just ask you, and you give me your thoughts.
Yeah.
John is asking, so there's a lot of thought and design you'd have to put into your personal project to maximize efficiency and reduce costs?
100%. Yeah. For SQL and NoSQL.
Okay.
Yes.
So yes, John.
Yes, there needs to be a lot of thought.
Alright. I think that would conclude our presentation.
Cool. Awesome. Well,
I think this was a huge success. What do you guys think? I don't know if they can hear me from this far out here.
Diego asked how it went. I liked it. Thank you guys for coming. Again, we're probably gonna talk for a little more in the Discord chat. Saturday at 4:30, we're doing leak code. If you're not familiar with leak code or don't know where to get started, for interviews, for kind of like updating and upgrading your resume, feel free to reach out to me or any officer. But I guess the short answer, if you don't want to reach out, is just do personal projects. Just go to YouTube, even like cheap Udemy courses, and look up whatever you want to learn, whether it's, again, MongoDB, if it's Firebase, or something super simple like creating a simple website. You may not think you're doing a lot, but you're definitely adding on, because we've all started somewhere. So just kind of learn the basics and then just keep working your way up. Awesome. Well, thank you guys. If there's no more questions, probably in the chat. We'll hop in the Discord. Shout out to my favorite playlist, Lo-fi playlist. I like it. It's pretty good.
Alright, bye everyone.
Bye, you guys.